All right, so this says Tyler's on a school baseball team, and he had 24 base hits out of 110 at-bats this year. What is his current batting average? So the way we do this is we take his number of successful base hits over his total number of at-bats. So that's going to be 0.218 as his batting average. Okay? He wants to raise his batting average to 0.30, right? So he wants to make 30% of his hits, right? Okay, how many of the next consecutive at-bats need to be base hits to raise his batting average to 0.30? Write and solve an equation to describe this situation using X for the number of consecutive base hits. Be prepared to explain how you write your equation and each of your solving steps. So when we write out this equation, we're going to take his batting average that we just found. Ooh, look at that 110. Okay, and we're going to add X to it in the top and the bottom. And the reason why we're adding X to it is that's the number of hits that he has to make in order to get 0.3 to be his batting average. Okay, so let me say that again. So X is the number of consecutive base hits that he's got to make right here. Okay, we're going to add that in the top and the bottom in order to get that 0.3. Now, if we're going to solve, we're going to cross multiply, right? Okay, so we're going to take this 110 plus X and multiply it times 0.3. And we're going to take this 24 plus X and we're going to multiply it by this invisible 1 down at the bottom. Okay, when we cross multiply, we're going to get 0.3 times 110 plus X equals 24 plus X. Okay, then we're going to distribute. So we're actually going to solve this out. So that's going to give me 33 plus 0.3x equals 24 plus x. We're going to subtract 24 from both sides. That's going to give us 9 plus 0.3x equals x. We're going to subtract 0.3x from both sides. Ooh, look at that handwriting. And that's going to give us 0.7x on this side and 9 on this side. The last thing that we'll do is we'll divide by 0.7 on both sides. I got you. And that's going to give me 12.86. 3, it says, unfortunately, Tyler gets no base hits in the next 3 at-bats. Revise your equation and then calculate how many of his next consecutive at-bats need to be on base hits to raise his batting average to 0.30. So Tyler is really bad at baseball. That's what we're getting from this, okay? So we're going to take the exact same equation that we had on the last one. So we're going to have that 0.3 equals 24 plus x over, but instead of writing 110, we're now going to write 113. Okay, and the reason why I'm going to write that 113 is because he got no more of those on base hits, or in base hits, no base hits. Okay, so he just kind of missed. Or anybody play baseball? Yeah, okay, so he swung and he missed, right? That's what he's saying, right? Right? Right. Okay, cool. All right, so now you're going to cross multiply and you're going to solve. So it's the same exact process that we did on the last one. So we're going to cross multiply and we're going to solve. So we're going to do 0.3 times 113 plus x equals 24 plus x. Go ahead and take a moment and try this one on your own. Try to solve it. So when you distribute this, you're going to get this, 33.9 plus 0.3x equals 24 plus x. You're going to subtract 24 from both sides. That's going to give me 9.9 plus 0.3x equals x. You're going to subtract 0.3 from both sides. Now, the way I get 0.7 is I take 1 minus 0.3, and that gives me 0.7. Divide by 0.7 on both sides, and that's going to give me x equals 14.4. So how many actual hits does he need to make on this one? He needs to make 15, right? Because you can't have half a hit, right? You gotta take a whole hit, right? So he needs to make 15 consecutive hits in order to raise his batting average to 0.3. Are we good on this one? You guys know maybe?
You explained that one
1 minus 0.7. So there's this 1 right here, minus 0.3. That gives me 0.7.
Are you ready to go?
He said, nope. What's up?
Are you good?
I slightly don't understand this problem, and here's the reason why. So, Elena had 24 base hits in 110 at-bats. She's done a lot of practice and now thinks that for all of her future at-bats this season, she'll have a batting average of 0.35. If she does, then how many more at-bats will Elena need so that that with this average, she reaches a 0.3 batting average for the whole season? That's what I'm saying. So why would she want to go from 0.35 down to 0.3? I'm not sure, but here we are, and this is math. It's like, how many watermelons does Johnny need? It's fine. So you're going to do 24 over 110, right? Because that would be her original batting average. However, now you're going to add 0.35x in the top, and then you're going to add x in the bottom, because this is talking about having 35% of the next consecutive on-bat hits, or on-base hits. Okay? And we're going to set that equal to 0.3. Yeah. I'm not sure. Okay, so now what we're going to do is we're going to cross multiply, right? Okay, and then we're going to solve this guy. So we're going to have 0.3 times 110 plus x equals 24 plus 0.35x. Sorry, that's going off the page. 0.35x. One day I'm going to have good handwriting. Today's not the day. All right, so when I distribute this, that's going to give me, this says 0.35x. So when I distribute this, I'm going to get 24.35x on this side, and I'm going to have 33 plus 0.3x equals 24 plus 0.35x. Every time I run out of room on this side.
That's a 0.35.
Yep, 0.35 on that side. Okay, so now I'm going to solve. So I'm going to subtract 24 from both sides, and that's going to give me 9 over here, plus 0.3x equals 0.35x over here. I'm going to subtract 0.3x from both sides, and that's going to give me 9 equals 0.05x. We're going to divide by 0.05 on both sides, and that's going to give me x equals 180. Okay, so she's going to need to make 180 more bats, like on base hits, right? Yeah? 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 9 divided by 0.5? 0.05? Yeah, 0.05. 180. Yeah. Okay, so Noah likes to go for boat rides along a river with his family. In still water, so that means like nothing's going on, he's just chilling. The boat travels about 8 kilometers per hour. In the river, it takes them the same amount of time, t, to go upstream 5 kilometers as it does to travel downstream 10 kilometers. If the speed of the river is r, write an expression for the time it takes to travel 5 kilometers upstream and an expression for the time it takes to travel 10 kilometers downstream. Okay, so first thing, upstream versus downstream. Okay, I don't know if you know this, but it's a lot easier to travel downstream than it is to travel upstream. Okay, like if you're swimming with the current, it's a lot easier. If you're swimming against the current, a lot more difficult. Okay, so we write out for upstream, it talks about 5 kilometers upstream. So we're going to put 5 up in the top. Now, we know from this, we've got 8 kilometers per hour if it's in still water. So that means that in the denominator, we're going to have 8 minus r. R is representing that amount of time, or the speed of the river. I'm sorry. R represents the speed of the river. Now, if we're traveling downstream, we're going to use that 10 kilometers downstream over 8 plus r. Because remember, it's easier to travel downstream, right? So we're following with the current when we go downstream. Yep, that's why the upstream is negative. So somebody noticed there's a negative here, there's a positive here. All right, everybody okay on that so far? Now, on part 2, it says, use your expressions to calculate the speed of the river. So what you're going to do is you're going to set both of these equal to each other. Okay, so you're going to write 5 over 8 minus r, and you're going to set that equal to 10 over 8 plus r. What do you think you're going to do in order to solve this? Cross multiply, right? So that's going to give us 5 times 8 plus r. We're going to set that equal to 10 times 8 minus r. So if we solve this, we're going to distribute, and that's going to give us 40 plus 5r on this side, and 80 minus 10r on this side. So now we're going to solve. So we're going to subtract 40 from both sides. That's going to give us 5r on this side equals 40 minus 10r. We're going to add 10r to both sides. That's going to give us 15r equals 40. Divide by 15 on both sides. So r is going to equal 2.67 kilometers per hour. So on number 3, you should have gotten 4 over 5 minus x, or whatever variable you used, is equal to 16 over 5 plus x. Okay. The reason why I put this minus over here and this plus sign over here is because this is kind of like saying upstream. This is going downstream, right? The reason why it's addition is because, like, when you go downstream, you're following with the current. So you're taking whatever the current's speed is plus whatever the boat, canoe. What does a row team use? Canoe? Kayak? Something? Like, I'm going to multiply this times this and that times that. Yeah. So 4 times 5 plus x equals 16 times 5 minus x. Yep. Okay, so when you multiply these, you're going to distribute. So you're going to get 4 times 5. I'm going to write this down here, but then I'll erase it in a second. 20. And 4 times x, that's going to give you 4x. Over here, that's going to give you 80 minus 16x. I'm going to solve, so I'm going to subtract 20 from both sides. That's going to give me 4x equals 60 minus 16x. We're going to add 16x to both sides. That's going to give us 20x equals 60. But divide by 20 on both sides. X is going to equal 3. All right, so on number 4, I'm going to make sure that you set it up right. So it says a plane takes off from Atlanta and flies 910 miles with the wind. That's like going downstream, right? Okay. And then it says 660 miles against the wind. That's like going upstream, right? Okay. And then it says 305 miles per hour if it's just chilling in the air. So when we write this, it should be 910 over 305 plus x. We're going to set that equal to 660 over 305 minus x. You're going to cross multiply. And so that's going to get you 660 times 305 plus x is equal to 910 times 305 minus x. When I distribute, I'm going to get 277,550 minus 910 or x equals